First, I wanted to mention what are the goals of this course. So I would say they're threefold. First of all, I wanted to give you an overview of what is the state of the art in natural language generation. What are kind of the hot topics in the field right now? It's a field with very long history also, and we won't be doing justice for the history, so we won't be covering many of the historical methods, although we do cover some of them even during this course. But this is more about the recent advances. And second, I also want to focus on something which maybe not so much the other courses you may have taken focus, which is about the practical considerations. So let's say you wanted to build a company that does NLG in one form or another. What would be some of the practical considerations that you need to take into account? So how would you be able to, for example, serve your model to a large number of users very quickly and optimize things like this? So that's what the third lecture is going to be focusing especially. And some of the papers also that we're discussing during the seminar will be discussing also the practical issues. Finally, given that it's mainly a seminar course, the goal for you will be to learn to digest, so learn to kind of read NLG papers, and I would say this should be useful for reading papers in general if you don't have much experience in that. In my experience, the more you read papers, the faster it becomes to read and understand them, because you kind of, when you're reading papers, you're building some kind of mental map of what are the current trends and the different things that usually are discussed in the paper. So it's going to be much faster to position future papers that you read once you have more experience. And since you're also going to discuss these papers and present these papers, it should also help you to disseminate, so kind of tell about this research to others in an understandable way, which is very useful, especially if you're in academia. But I would say, at least in my own experience, it's also a very useful skill on the industry side, because often, like a lot of the methods, at least what we develop, they're inspired by some of the recent works in the academia. Okay, and regarding the contents of the lectures, as I already mentioned earlier, the first lecture is going to be about what is NLG and sort of what are the main applications of NLG. And I'm also going to talk during this first lecture a bit about what are some of the methods that have been used this for a bit longer time before the neural network revolution, but which I think are still today very relevant. So it's useful for you to know them, especially if you want to build something practical around NLG. Second lecture is going to focus on the methods. So we're going to talk about all these recent large language models like GPT-3 that comes up a lot also already during this lecture. But so what are, how do these methods work, and what do they have in common, and things like that. And then the final lecture is going to be more about the practical side. So how do you go from the theoretical method description to deploying these methods in practice? And this involves things like how do you evaluate these methods? How do you build training data sets for these methods? And what are some of the ethical considerations when deploying these language models? Okay, so let's jump into the first lecture. So what is natural language generation? Hopefully most of you already have some kind of idea. Often you see the term text generation used pretty much interchangeably with the term NLG. And one simple way to define this would be that NLG methods are methods where the output is natural language, as the name suggests. So what is natural language? It refers to languages that have evolved naturally in humans. So for example, Finnish or English would be natural languages, in contrast to, for example, formal languages that you may have encountered in some of the kind of the first CS courses that you've taken. This definition where the output is natural language is not, however, kind of bulletproof. So for example, automatic speech recognition the output would be natural language, but I still wouldn't necessarily label this under NLG. Also, actually, some of the methods developed for NLG, they can be used also for generating other than natural language, for example, code. And we're going to see one example of this at the end of this lecture. And another way to look at is, and yeah, by the way, so if you look at if you read some of the more traditional literature, NLG, and maybe even these days, some people would say that NLG is specifically about going from data or structured data into text. So not going from natural language to text or from text to text, but from some kind of data. And we'll see examples of what this data might be. But in this course, I'm going to use the term more broadly to refer to various kind of approaches where the output is text. So the input can be not just structured data, but also it can be nothing. So you might be just generating text out of nothing without controlling it in any way. It could be that you're given a prompt, so some kind of text that you need to complete. This is another very common sort of setting, and for example is GPT-3, where kind of this setting where you're trying to complete the text. It could be also text that needs to be rewritten in some way. For example, you need to rewrite it in a different style, and we're going to see more examples of this approach. And then I mentioned the structured data. Also, there's a lot of literature on things like automatic image captioning or video captioning, but this will be outside the scope of this course. Another important application is machine translation, which would kind of naturally fit under NLG in the sense that the output is text and input is text. However, it's kind of its own field, so I won't be covering machine translation during the lectures. However, we will be having few papers that have machine translation as the main application. And I think it's important not ignore this field, also because many of the methods that are used for sort of NLG applications outside machine translation have originally been developed for machine translation between different languages. And then, as I said, the output is usually text, but it can be also other things like code. So if we zoom out a bit more, why should you care about NLG? So I would say that natural language is the main way we communicate with other human. Of course, there's nonverbal communication and so on, but that's basically how we convey ideas and try to convince others is through natural language. So it's very important between human to human communication, but also, and it's becoming, it already is, and I would say it's becoming more and more important to the communication between humans and devices. So if maybe you have also grown up kind of in an age that natural language is not the main way or kind of the main media through which you communicate with your devices, but already now you have all these kind of virtual assistants that you can communicate over natural language. And also, if I look at, for example, my kids, for them it's very natural to talk to something like a Google Home device or something, whereas I myself haven't grown into using this until some recent years. But so if you want to build natural language interfaces between humans and devices or humans and machines, then NLG is what you use basically for the other direction of the communication. So how do you make the machine communicate information to the human via natural language? However, interestingly, I would also say that it's very important part of, or it can be also of great benefit for improving communication between humans. So we're going to be seeing some applications around writing assistants, basically seeing how can natural language generation methods improve the communication from one human to another. And finally, it can actually even, so the methods developed for NLG can even be used to improve communication from human to a device through the application of code generation. So basically, uh, applying these methods like GPT-3, you can more easily and more effectively, in some cases, communicate your ideas and instructions and commands to a machine. Uh, Another way and another big motivation for the work in NLG takes its roots already from the very famous Turing test. So, in his seminal paper from 1950, Alan Turing he tackled the question of, can machines think? And it's, first of all, I would say this. I hadn't read this paper before this preparing for the lectures, but it was very fascinating paper because it looks very different from the computer science papers these days. So you might want to take a look. There's a link in the slides. It's written in a very different style. So basically, Turing starts the paper by saying that the question, can machines think? It's kind of hard to tackle because it's hard to define what exactly does thinking, or what exactly does machines refer to. So let's instead consider the following alternative question, which is kind of closely related, but it's defined in much more unambiguous words. And the question here is that, and he proposes what he calls imitation game, which is also the name of this fairly recent movie, where you have an interrogator who's a human and who is interrogating two subjects. And the interrogator doesn't see these subjects. One of them is a human and the other is a machine. And the task of the interrogator is to infer which one of them is human and which one is machine, while the machine tries to kind of trick this human. So try to convince that the machine is the human. And this is obviously something that you need NLG for if you want to pass the Turing test. It's also I would say that you can find many papers in the NLP field where the evaluation of the paper is inspired by the Turing test, in the sense that you have some kind of side-by-side setting where you show a human rater two outputs, one generated by a model and one by a human, and then the rater is supposed to pick up the one they think is generated by the machine or by the human. Okay, if we again zoom a bit more out, so we already talked about NLP, and as I said, there's overlap between the methods developed for other NLP tasks and NLG. So kind of the two big areas under NLP are NLU, which refers to natural language understanding, and then NLG. And NLU basically means tasks like where the input is text and you somehow try to understand. So for example, you try to classify the input sentence to something. But things like BERT, which was originally developed for NLU, it has also found many applications in the field of NLG. Then there are also some methods that I would consider NLP, but neither NLU or NLG, something like pre-processing text and tokenizing text and things like this. Okay, but so let's focus a bit more again on the NLG specifically. So I mentioned that the traditional NLG line of work is focused on the data to text. And so what is this data? Applications that would fall under this category would be things like automated journalism, where you have some kind of things like sports result and you're generating a report based on them. And I'll now go through these quickly. We're going to look more closely into some of these. Then you have goal-oriented dialogue systems or virtual assistants. Accessibility is one application that can be very useful, where basically for people who are, for example, vision impaired, you can generate descriptions of visual data like graphs and tables using some NLG methods, so that then then this information becomes accessible to these people as well. And one kind of more traditional application is thing like summarizing medical records automatically. On the other side, for the text-to-text applications, and I mentioned that NLG methods can improve human-to-human communication. So you have various kinds of writing assistants that do things like grammatical error correction. One very popular field or subfield of NLG in academia especially is automatic summarization. So how do you summarize a large chunk of text into the main points? And there are many kind of popular benchmarks. So often NLG methods are evaluated at least on some summarization task. Then I already mentioned goal-oriented dialogue systems, but then there are also chit chat bots that are just about chatting about anything. One pretty large field is creative applications that we're going to be talking a bit more about today. Then maybe a subfield of this is games assisted by an NLG system. So you might be generating, for example, a storyline for a game using some NLG system. And finally, code generation is sort of a recent application, or which has recently become quite popular in the field. Okay, so we're going to look a bit more closely into some of these. But before we do that, I'd like to do a small poll. So let's start looking at some of these applications. So one that I mentioned that's under the data to text subcategory is automated journalism. And this is, at least those of you who speak Finnish and read news may have, or probably like to have seen some application of this. So in general, this is used for things like sports, where you have lots of results coming at a quick pace, and usually the data has a very specific structure. So you have the results of the games and things like who scored goals and things like this. So there are systems that generate reports based on soccer results or other sports results. Another similar field is weather reports, where again the data is very structured, has a specific structure. What I mentioned about Finnish, I saw a few years ago that Yle was working on a bot or NLG system for reporting about election results. Again, here the data comes out at specific times, and usually the different news agencies, I guess they kind of compete who's the fastest to release out some stories on the results. So automating this is a way to make it very fast and scalable. And finally, finance is another application. So as I mentioned, one clear advantage of this is that it's a very fast way to generate news stories. It can potentially be cheaper and more scalable. But then on the other hand, you have all the questions around credibility. How can we ensure that the algorithm isn't generating something that's not factual? So the term hallucination refers to the thing where NLG system generates something that's not based on the input or is non-factual, and this is a very common problem tackled also in the academia. Sometimes if I read these automatically generated stories, they kind of get a bit repetitive because often they're based on this kind of template system where the machine would always usually say the thing in the same way. So it can be not so nice to read. And also there are some more threatening applications. If you have a good NLG system for automated journalism that you have some control over, you could also use it to generate fake news in large scale. Okay, and as I mentioned, this is one of the sort of ethical considerations around NLG systems in general, and we're going to talk a bit more about it in the third lecture. So the next system that is related to my own work is dialogue systems or chatbots and conversational agents or virtual assistants. There are many names which have a lot of overlap, but they're not strictly referring to the same thing necessarily. But a lot of these large tech companies have some kind of virtual assistant, like Siri is quite well known, Amazon Echo, Google Assistant. And one of the older ones that's different from the others, it's called Eliza. It's already from the 60s, which is a chatbot therapist. And you can go and try it out if you haven't. I mean, it's not nearly as kind of, the tech is quite basic, but even this fairly simple system can kind of keep people quite engaged. So then if you look into these dialogue systems, you have different ways to classify them. One would be chit chat versus goal oriented. So goal oriented dialogue system is something that tries to help you achieve a goal. So basically, let's say you want to make a reservation, and the dialogue system asks you the right question, so that it elicits the necessary information for making the reservation, for instance. There's also a related category, so open domain versus closed domain. So open domain, you can talk about anything, but then closed domain chatbot would be something that's designed to only do one specific thing or a set of specific things. Sometimes like some companies have automated customer service over phone, where it's very closed domain and it can be very rigid and not easy to get your thing done. And then finally, more on the methodological side, there are end-to-end systems. So I guess often these chit chat bots or open domain things are end-to-end, where you have a single neural network that tries to do the whole thing, versus pipeline systems where you have different components that try to tackle different things, like the natural language understanding part and then the NLG part. And just to give you a concrete idea, in case you haven't used any of these virtual assistants, I'm going to play a short clip from Google I/O, which is the annual conference where Google presents new tech. This is already 3 years old, but I think it's still a pretty cool demo. So this gives you an idea of things that assistant can do. So let's look a bit more closely into what goes into building a dialogue system. And now I'm going to present sort of a pipeline approach. This is largely inspired by a recent book by Roberto Pieracini, who is one of the directors at Google in Zurich. So he has written a book called AI Assistant. This is very, very nice introduction to the field, so I encourage you to look into it if you're interested to learn more. Okay, so what we start with is that we have some kind of speech signal. Then the first step is the automatic speech recognition that many of you in this course are experts in, which turns the signal into natural language. So now you have the query like weather in Helsinki. Then you have an NLU system which takes this text and tries to understand what it's about. What does the user want? And the output can be in various forms. One example could be that it produces some kind of structured representation for the query. For example, that the intent of the query was to learn about weather, and the location attribute is Helsinki. Now this structured representation or symbolic representation goes into Dialog Manager. So Dialog Manager is responsible for retrieving the answer or retrieving the information to answer the user, and it interacts with some kind of database or the digital word possibly to retrieve the answer. And it would, in this case, it would output something like some structured output where you have the answer like the temperature is one, where the unit is Celsius and the condition is raining. And then, so now comes the role. Now you see where the NLG starts to play a role in this pipeline setup. So NLG system would consume this structured representation and would produce a natural language output that is then spoken to the user after passing it to a text-to-speech system. Okay, so as you see, NLG is actually kind of a small part of the full system when we're talking about dialogue systems. There are many other components, and And usually different teams are responsible for the different components because all of these are quite complex and require a lot of work to do them well. So how do we do the NLG part then specifically? And one very traditional way that's common, there are papers on this, and I think this is, I would estimate that in industry this is a very popular even up to this date, is where you have some kind of templates. And a template could look like the following. So it will be temperature and condition, with the idea that then you fill in the values from your structured data to these placeholders in the template. And the advantage of this approach is that it can be very simple. You don't need to train any model, which means you also don't need to collect any training data. You just need someone to author these templates, in assuming that you have a limited set of messages that you want to convey to the user. Another thing I already mentioned, hallucination is a very common problem, especially with these neural network-based approaches. But here you don't have to be afraid of hallucination because the template system will output exactly kind of the message that you wanted. Okay, so it seems all good so far. However, it's actually not always that simple. So if you look at messages like, consider a message like, here's the traffic in location. Now, depending on the value of the location argument, you would need to use different preposition before the location and potentially insert the determiner. So, for example, here's traffic in San Francisco at the Golden Gate Bridge or on 101. And moreover, if you start to internationalize these templates, so you start translating them into other languages, often this brings a lot of more challenges, especially once you move to languages that are, for example, morphologically richer, such as Finnish. So if you had a message like you have X new messages and you wanted to internationalize it into Finnish, now depending on the value of the number argument, you would also need to change the adjective new, so it would be either sinulla on yksi uusi viesti or sinulla on kaksi uutta viestiä. Even in English, you'd need to, this S would be go away if you have just a single, but in Finnish you also need to change the adjective. Okay, so you see it's not necessarily super straightforward. However, maybe if you have some linguists who can help you with this, it's still possible to build a system that is able to output grammatical messages when you just encode all the rules of the language. So kind of the first takeaway I'd like you to take from this course is that if the problem is such that there's a way to solve it without machine learning with some set of simple rules, I would say that don't use machine learning, because you always run into these challenges. How do you collect the training data? How do you make sure that the model doesn't hallucinate or produce some unpredictable output? So yeah, if you don't need it, don't use it, just for the sake of using it. Of course, there are other considerations. If you're, I don't know, raising funding, maybe you want to do it to look cool. But I mean, if you just want to build a system that does the job as well as possible, it's not always the best solution. However, there are many cases where it actually makes a lot of sense to use machine learning. So let's take a look at another application of a dialogue system. So this is something I've actually been working on myself some years ago. And so here the case is sometimes users ask queries that are quite ambiguous in the sense that there are many different aspects in which you could answer. So for example, if you ask about, tell me about Madonna's birth, you might see an answer like this, where when on display, you see multiple aspects like date of birth, full name, place of birth, and so on. And now if you want to generate a spoken response for this answer, then the question is, how do you do the generation? How do you do the NLG part? And one kind of simple way is that maybe for each of these attributes, you have a template so that then you can just realize each attribute separately and concatenate. And in this case, you would get an answer like Madonna's date of birth is August 16th. Madonna's full name is so-and-so. Madonna was born in Bay City, Michigan. But as you can tell from this answer, this easily gets very repetitive and doesn't sound very natural. So the question we started looking into, is there some better way of doing this? And so this task is the task of sentence fusion, which we can define as given two or more answers, fuse them into single coherent answer. To give you yet another example, if the query was about Einstein, you might want to summarize the three answers you see on the screen into something like Albert Einstein was born in 1879 and he died in New Jersey at the age of 76. So we talked a bit about summarization earlier. This is also, you could see as one sort of instance of abstractive summarization. But kind of the task here is that you remove unnecessary repetition and you add some glue words between sentences. So how do we do this? Well, the first idea that might come to mind is let's use the templates, given that we already have them for the individual answers. So let's write a fusion template for each answer template combination. But you can, as you probably realize, even with very small number of templates, so if you had only 100 templates, we would get already something like 4 million unique combinations of 2 to 4 answers. So obviously this doesn't scale when you have this kind of combinatorial problem that you start combining multiple answers. So this is a great example of use case where machine learning comes to the rescue. So assuming you can learn a model that learns to generalize to unseen combinations, you can solve this task efficiently with machine learning without having to put a lot of manual effort into writing templates. So how exactly you can do this? We have published a few papers on this, and I'm going to talk more about one possible approach for this next week, specifically about this encode tag realize high precision text editing work that we did, we published a few years ago. So then let me move to the next application, which is around writing assistants. So these are AI tools that help improve human written text. And often these are for fixing grammar, but there are also things that help you complete text. For example, the smart reply in Gmail proposes, and you see this in many, I've seen this at least in LinkedIn, where you get some recommendation or kind of option of how you can quickly answer a message that you've received, and then you can of course modify this answer further, but just to make the message writing faster. And there are many academic tasks related to this area. So grammatical error correction is a big one that your project work is going to be related to. Then language modeling, which is basically the task of completing an incomplete sentence or prompt, is related to this kind of predictive text applications. Then there are things related to style transfer, for example, changing the style from complex language to simple language, which is also called text simplification, or changing the style from formal to informal. This is a very big area in academia. Sentence fusion, which I already mentioned, is one area. And then also the opposite task of automatically splitting long sentences into shorter ones. And then finally, summarization that we already covered. Related to this, I saw recently there was a news about the Finnish startup that raised fairly big funding, which is also in this field of writing assistants, where the idea was something like the user writes a short description of what they want to convey, and then it automatically generates the full email for this. So this is a very nice, and I think it mentioned that they use GPT-3. So this is a nice application of NLG and how it can improve the communication between humans. Games, we already touched on this. So AI Dungeon is the game by OpenAI, or I don't think it, I'm not sure if it's official by OpenAI, but at least it's powered by GPT-3 or GPT-2. It can be quite entertaining, so I'll encourage you to give it a try. so basically all the interaction is over text, and then the answers are generated, and it's kind of an open world, and it's not kind of pre-scripted. So yeah, go ahead and give it a try if you're interested. Also, if you're interested in this field, there's a course that looks very cool called Intelligent Computational Media by Perttu Hämäläinen, who's professor at the CS department at Aalto. There's also some public material you can go and check out if you follow the link in these slides. So I will, by the way, put the slides and the recordings of the lecture afterwards to my courses. Then another area is about creative applications. So these are things like how can you automatically generate poetry or lyrics or screenwriting for a movie. And this is, again, very active research area. There's at least one dedicated conference to this. And here, like, there are some works that try to sort of fully automate, but often what I find more useful is some kind of co-creation between human and machine, where the algorithm is trying to augment human creativity by, for example, offering some suggestions instead of the model having full control. And so I'm going to, I realize we don't have too much time. We have something like eight minutes. So I mentioned in the beginning that I did a side project on NLG, which is, and we published a paper during my PhD called DopeLearning, Computational Approach to Rap Lyrics Generation. So I wanted to quickly talk about this because I think it quite nicely illustrates some of the key concepts in the field of NLG. It's not, I wouldn't call it recent anymore, but some of these techniques are still very relevant. So let's just quickly go through some of these and we'll finish by 12. Okay, why would you want to look into rap? I think what makes rap kind of special, obviously I'm biased because I had been listening to a lot of rap during my studies and I found it interesting because of that. But there's also a lot of structure in rap lyrics in the sense that they use these complex rhyming patterns in addition to trying to tell some kind of story. Okay, I'm going to skip this. And so what are these complex rhyme patterns? Often in rap lyrics, so first of all, it's not so much about consonants, but they use these vowel rhymes, right? Like baby and crazy would be considered a rhyme. And then specifically, they use these multisyllabic rhymes. And many rappers try to create as long multisyllabic rhymes as possible because it's considered to, at least in some cases, to improve the flow. So you would have something like, I get paid to sling some raps. What you made last year was less than my income tax. So sling some raps and income tax would be a multisyllabic rhyme. Okay, so I mean, during my PhD, I first, just as a small side project, I made this software for detecting these rhymes and sort of analyzing which human rappers use the longest and most frequently the multisyllabic rhymes. I created a ranking, just published on a blog post, and it got quite a lot of attention in the media because there's a lot of debate about who's the best rapper of all times and so on, which obviously this doesn't answer, but it provides you some data related to that question. So, and the nice thing about this publicity was that actually one rapper reached out to me and asked me to analyze his latest album with this software. So, which I happily did, but I thought that could you first, before I give you the results, tell me what do you think are the most technically kind of most skillful lyrics in this album? And we found out that actually this ranking created by the artists themselves quite closely correlates with the ranking by the algorithm. So this was sort of a validation that the algorithm is capturing something real. Okay, so obviously, as I said, I hadn't been working on NLG, but then kind of the natural next step is if you can analyze, can you also generate lyrics? And now that we have this ranking, we have some way of comparing. So that led to the paper that I mentioned. We published in 2016, where we released the DPID, which is a rap lyrics generation. And Now the method I want to highlight here is that we did it not from the scratch, just generating word by word, but we used what is called retrieval-based approach. So you take lines from existing songs and then you combine them in novel ways, with the goal that you would combine lines that rhyme well and also kind of semantically fit well together. And you can fit a well-defined sort of machine learning task. So given existing songs, take the first k lines, try to predict the k plus 1th line, given a set of candidate next lines. And now you have a way of easily measuring how accurate is your algorithm. And then you can use the same method to generate new lyrics by always predicting the next line, but just making sure that the algorithm never picks up the true next line, so that or it doesn't pick the line from the same song as the previous, so that you don't end up just replicating existing songs. Okay, there's a demo song that we recorded based on this. I won't have time to play it, but you can go and check it out later if you want. Okay, it's pretty good, I would say. So this was it was a student from MIT who had seen our paper, and he reached out to us and saying that he could record a song because he was also a rapper. So go and try it out. Okay, we found, obviously, now that we explicitly optimized for this rhyme density, we can do very well with this particular metric. And again, this generated some quite nice headlines, obviously over exaggerating the thing. But okay, this is kind of what got me excited in the area. We also continued this work and build a tool, dp.org. You can also, this is still running online, and this is more about how you can create lyrics together like human and machine. So you can ask for suggestions for the next line, you can write some of the lines yourself, and this is still pretty actively used. So I think it has more than 1 million page views as of this date. Okay, I won't have time to cover this now. But what I just wanted to say is that this is one illustration of retrieval-based NLG, where the idea is that you have a database of responses, and then the task of generating the response is reduced into just retrieving the most appropriate approach, which greatly simplifies the problem, and it can make your algorithm much more efficient. Of course, on the other hand, it's quite a rigid approach. So also in these rap lyrics, you often see that there's no smooth transition between consecutive lines, but it kind of doesn't sound natural. And then later we did some follow-up work where we used some transformer-based models to do this in a more natural way. Okay, also one practical aspect is that once you have this database of answers, then you can easily, like if it turns out that there's some problematic answer, you can just remove it from the database and you don't have to touch the algorithm in any way. Okay. Yeah, actually, I think we're almost out of time, so I'll need to finish here and we can continue next week in this area. But I hope this, or actually, let me just skip. I wanted to talk about code generation a bit, but you can check out the demo. It's pretty cool by OpenAI.
Hello, everyone.
We can briefly discuss next week. What I wanted you to take away from this lecture is that hopefully you've been convinced that NLG has many applications and many exciting applications that are also useful. It can support not only computer to human communication, but also the other way, human to computer via code generation, and also human to human. And then we saw two previous approaches, namely templates and retrieval-based, which is still valid these days. So, okay, next week we're going to talk more about the method side and about the papers, and I'll give some details on the project.